Hello. Hi guys. Hi. Hello. Cool. Right. So yesterday, uh, okay. So today there are a lot of topics to cover. So let's not waste any time, and let's quickly go through what we studied yesterday. Right. And also, am I audible? Can someone give me a little feedback on the chat if it is possible? Okay. Nice, nice. Okay. Yeah. So yes, cool. Okay. I'll start the class. Right. Today there are a lot of topics to cover, and yeah, so let's quickly go through what we did yesterday. Right. So we did not do these two topics yesterday. Right. So I'm going to cover these two today. So yesterday we went through how like what happened with C, and then how Java works, what is JVM, Java Virtual Machine, JDK, JRE, runtime environment, and all of these kind of things, like what are the naming conventions and language rules, and how we go through, how what are identifiers, how we go through them, and what we actually do, how many reserved words are there in Java, and so on and so forth, right? So we went through all of that. Now today we are going to have some more stuff. Yesterday I missed out on data types and operators, right? So I'm going to cover them today as much as possible, and we'll see if we can cover flow control methods and call by value, right? If not today, we'll cover them tomorrow, right? Okay. So I'll go ahead and start, right? Okay. So before even going to data types, let's see what is the definition for variable, right? Variable is basically just just name given to some data, right? That is what variable is, right? So if you basically have int, so if you have int x equal to 10, right? For now, if you don't know int, it's okay. But if you have int x equal to 10, then you can think that 10 is created in some box, and x is given the name for that box, right? So that is what this variable is. So x here will act like a variable, right? And in the same way, uh, so every data that you see, like this particular data that you see, right? This particular data that you see here, 10, right? This data will generally have a type associated to it. Right now, since we have used int, that is the type associated to that particular data. And data type, coming with that particular way, what we can say is data type is basically type of the data that can be stored by variable defined. So this variable that you have defined here, int x equal to 10, right? The type of that particular 10 is integer, is what you're saying, right? Now, in Java, there are broadly, three types of data type, three types of data types, right? So three types are basically, um, you know, uh, numeric data types, character, and then Boolean data types, right? I'm talking about primitive data types, not object type data types, that we will look into later, right? And if you don't know what primitives are, these are primitives that I'm going to explain now. So in this we have int, or even before int, let's go with byte, and then int, and then short, and then long, right? And also we have float, we have double, right? And so in this particular character data type, there's only one particular thing, which is char, and then in Boolean we have one more, only one, which is known as Boolean, right? So these are the data types that we have, right? In data types, we are going to get into the specifics of the data type, right? So the specifics we have are basically for an integral. So basically these are all integral data types. These four. So these four that you see are integral data types, right? Integral data types. What do I mean by integral data types, right? store only store in, can only store integers, right? Integers. So that is the reason why they are integral data types. And so these two are known as floating point data types. And the reason why the reason why they are known as floating point is because we can store decimal values, or like values which have a radix, right? You have 23.673, right? This part is known as a radix, right? This part can float on the right or on the left, depending on whether where you want to move. So if you float it on the right, this point is floating. So that is the reason this data type is known as a floating points, right? So yeah, so this is a very brief thing about this. So we'll talk about some specific on the integral data type, right? So the specifics would be that every so basically byte, we have something known as byte, right? Byte is basically used for storing literally 1 byte of data, right? In general, you would not see usage of byte a lot, right? But byte is generally used to store 1 byte of data. And for byte, there are like 1 byte is 8 bits, right? 1 byte is 8 bits, and the range is minus 128 to 127, right? What do I mean by minus 128 to 127? Let's say if I have byte x equal to 500, right? This will not be stored as 500, right? This will not give you an there will be no error. But what happens is that it will what it will do is it will take x 500 as an integer, right? By default, every number like this is an integer. Every number like this is an integer, right? It will convert this 500 into like your binary system, right? Whatever they are, right? So it will only take the data from the last 8 bits. That's it. It will only take data from this last 8 bits, and remaining data that you have, right? Remaining data that you have, this particular data that you have will be cut off. So there is a loss of information, and whatever is the answer within this particular thing, right? Whatever is the possible byte data that is within this particular bits will be stored in our byte data, right? So you should always be careful about overflows when you are using byte and all, right? And the next data type we have is short, right? The range of short is actually somewhere between minus 32768 to 32767, right? This is not a magic number that I'm telling you. There's actually a formula, right? So it is 2 bytes, right? So with 2 bytes of data, so generally for n bits of data, for n bits of integral data, what we can say is that we can calculate the range using minus 2 power n minus 1 to 2 power n minus 1 minus 1, right? This is how we calculate the range, right? So when we have basically 2 bytes, right, which is 16 bits, right? 16 bits, 2 power minus 2 power 15 to 2 power 15 minus 1, right? 2 power 15 is minus 2 power 15 is this particular number, and 2 power 15 minus 1 is this particular number. Cool, understood? Moving forward, we have a size of int as 4 bytes, right? And 4 bytes, it is almost 32 bits, right? With the formula that we have, right, the range that we will get is minus 2 power 31 to 2 power 31 minus 1, right, for the range. And this is very close to around minus 10 power 9 to 10 power 9, okay? So that is the range here, right? In the same way, we have long is the long's size is 8 bytes, right? And it is 64 bits, right? 64 bits. The range that we generally have is around minus 2 power 63 to 2 power 63 minus 1, right? This is the range we have, and this is generally around minus 10 power uh, generally around minus 10 power 18 to 10 power 18, right? That is the entire full all full range of this particular thing, right? Powers of 2 and powers of 10 are interesting because we humans generally understand powers of 10. And one more note that I want to make here is that all integral data types, right? Integral data types in Java uh, are all are all signed. What do I mean by signed? Signed means that negative to positive is the range. Positive is the range, right? Is the range. Okay. In an unsigned data type, like let's say in C and C++, we have unsigned as well. So unsigned is a separate keyword in C and C++, right? In that particular case, what happens is that like a short, which has 2 bytes of data, if we use unsigned short, what happens is that unsigned short will be stored as minus so not minus, sorry, we have 2 bytes, right? But those 2 bytes will only be positive. That means the range will be something like 0 to 2 power uh, 2 power 8 minus 1, right? Which is around 0 to 255, right? In the same, so the formula basically for unsigned data type is 0 to 2 power n minus 1. This n is number of bits assigned to that data, right? So this is the formula, okay? But what you generally need to remember is this particular portion where you are saying that integral data types in Java are all signed, okay? And this is what you need to remember, right? Signed. Cool. Okay. Now moving on, we have specifics about other data types as well, right? When we talk about float, right, the range we have for float is 4 bytes and it is 32 bits, obviously, right? The way float so the way both float and double are stored are they both of them actually use something known as IEEE 754, right? Right, if you guys want, you can go ahead and read that, but quite frankly, if I try to explain this, it is very difficult. Basically, the idea is to store the data in scientific notation, okay? Scientific notation, and scientific notation just says that whatever data you have, let's say you have 0.00034, right, you generally store it as 3.4 into 10 power 10 power how many jumps do you need to make? 1 2 3 4. So it would be 3.4 into 10 power minus 4. That would be how it is supposed to store. So it will store 10 power minus 4 in some number of bits, and it will store 3.4 in some number of bits, right? That's how it works. That is the broad idea of how IEEE 754 works. And the very major difference between float and double is that so the major difference between float and double is that the precision, right? Float allows a precision of around 6 to 7 decimal places, right? Decimal places. And double allows a precision of around 13 to 14 decimal places. So that is the major difference, okay? And we generally, how do we write any code with float or double? Now if you write let's say if I write how do I say, right, yeah, if I write float f is equal to 1.56321, right, this will give me an error, right? Why? Because by default in Java in Java in Java uh, uh, decimal numbers decimal numbers are considered to be double. Okay, so that is the first and foremost understanding you that you need to, decimal numbers in Java are considered double, right? That is very, very important. So for this to work, right, what you need to do is you need to write float f is equal to 1.56321 f, right? That is how you make this work, otherwise it won't work. So this will work, right? For double, you generally just normally write it like double. So what you generally do is you write double k equal to 1.563213, right? This automatically is considered double, so this is fine. If you want, you can also add an additional literal in this particular area, which is 1.563213 d. This d or capital D or small d works here as well, capital F or small f works, right? So you can either do this or you can directly give like this, right? So by default, this particular thing is considered as a float on its own, right? Sorry, double as on its own. But if you want to say that this is not a double, this particular literal that I have is not a double, it's supposed to be a float, then you definitely have to give f at the end, right? The remaining data types that we have are character, and the size for characters in Java is 2 bytes, right, which is 16 bits, and this is the only type which has the range of 0 to 65535, right? And the reason is because it is using Unicode, right? It is using Unicode to store data, right? You can see that 0 is stored as space, 65 is A, 66 is B, 97 is A, 3077 is a Telugu letter called A, and then 2309 is a Hindi letter called A, right? So if you basically just say ch ch sorry, not c yeah, if you just do char ch equal to, let's say, 67, right? If you just do system.out.println ch, what will happen is you will print something like c as the answer, capital C, right? So that is how char works. Basically, it is used to store character data, right? You can also write char ch equal to x, right, like this, and you generally use single quotes to use the character data. So that's all about character data, right? Now you have boolean values. Booleans are generally just two values, true or false, right? To basically represent this, there is no size actually in Java. You don't have a size because, like, you just need one bit to represent this actually, 0 or 1. But in Java, 0 or 1 is not a concept. Like, 0 is not false and 1 is not true. In Java, true is true, false is false. So you have NA. So the size is actually in specific document it is not mentioned, and the range is also not applicable here, basically, right? So you generally just use it like boolean x equal to like something true or something like that, and then you can s out if x, right? If you do that, you should get something like true, right? So you need to remember that 0 is not equal to, so 0 is not, so basically you need to remember that 0 is not false in Java, and 1 is not true in Java. They are their own entities. They are not equal to each other, right? Unlike C or C++. Okay. Now we will quickly move on to operators, right? In operators, first thing we have to see here is that we have A, B, and C here, right? So A actually is A actually is an operand, right? Here B is an operand and C is an operand, right? In the same way, the remaining things that we generally have here, minus and plus, these two are known as the operators, right? These two are known as the operators. right? If you have a statement like this, right, this entire thing is known as an expression. Okay, right? A plus b minus c. And we are going to discuss about operators which some of these operators, arithmetic, and we are going to discuss about arithmetic, concatenation, increment, decrement, relational, equality, bitwise, short circuit, logical, and this we will cover later. But I have written it as an operator because this is supposed to be thought of as an operator, right? So this we will cover later. We will cover during object oriented, like when we start OOP, right? So typecasting is specifically not an operator, but it comes under the realm of operator only. And then we have assignment operators and then conditional operators, right? So we have these kind of operators, right? So what we generally have is in arithmetic operators, right? In arithmetic operators, we generally have plus that represent addition, right? So this is addition, this is subtraction, right? This is multiplication, this is division, this is remainder, modulo, right? Remainder, or you can also call modulo operator, right? For given scenario, if let's say a equal to 10 and b equal to 20, right? I think most of the people know how to answer these questions, right? We will quickly go through. C equal to a plus b, which will be 30, and then d equal to a into b. 10 into 20 is around what? 10 into 20 is around 200. So d will be 200. A by b, 10 by 20 is around 0.5. But since this is an integer, right, we will not be able to store 0.5. We will store 0 here, right? And then f equal to a percentile b, right? 10 percentile 20 is here is 10, because how do we see it as 10, right? You do 10 by 20 and you get the remainder. What is the remainder? 10 20 divided by 10. 20 when it divides 0, you get 0 and you get 10 as the remainder, right? You actually have to use 0.5 to completely divide it, but since you cannot, you generally don't do that in computers, right? So you just do a long division and just find the least number that is possible, like that is in line with 10, like less than 20, right? A minus b, 10 minus 20, this is very straightforward, this is minus 10, right? So that's all about arithmetic operators. And we have the next set of operators that we generally have is concatenation operators. And again, we will take a very small example to understand what happens. So what happens is basically that we have concatenation operators, right? So if I have a string called a and it is Java, and if I have b integer b 10 and c equal to 20, d equal to 30, right? What will happen if I do if I generally do a plus b plus c plus d, right? What is a plus b plus c plus d? It's Java plus 10 plus 20 plus 30, right? What actually happens is you will get Java 20, sorry, you will get Java 10, 20, 30. That is what you will get. Basically what you need to understand is that in Java, if you do something like string plus anything, right, you will get string at the end of the day. So that's how this works, right? So for example, right, for example, if I do something like if I do b plus c plus d, right, this b plus c plus d, if I do this, what happens is 10 plus 20 plus 30 happens first, because there is also one more rule here, and that rule talks about operator associativity, right? Due to operator associativity, what happens is operator associativity. What do I mean by operator associativity? Very briefly, let's discuss this, right? What I mean is very simple, right? So what I am saying is very simply, this particular plus is generally associated left to right, is what I'm saying. That means if there are, if we say, if we have a plus b plus c plus d plus e plus f, right? First a plus b will be done, then answer of a plus b will be solved with c, then answer of this entire thing will be solved with d, the answer of this entire thing will be solved with e, the answer of this entire thing will be solved with f. So it is always going to associate from left to right, left to right. The same goes with minus, the same goes with multiplication, but the only difference is division will associate from right to left. Okay. So there are some association rules. There is a table called operator precedence table, that if you can check that out, it would be very nice. You will be able to understand a lot of stuff there, right? So that is what happens when you do operator associativity, right? So I'm gonna decrease the size of this so that it is still there here. Okay, cool. So what we generally have is that whenever we do b plus c plus d plus a, okay, so b plus c plus d will happen first. So b plus c plus d plus a is there first, b plus c will happen, then b plus c plus d plus this will happen, and then this will happen. The answer for this will be uh, uh, 10 plus 20 30, and then the answer for this would be 30 plus 30, right? 60. So 60 is now being attached to Java, right? That is what the answer is. The answer would be 60 Java, right? You can try it in your compilers, right? In the same way, b plus c plus a plus d, right? B plus c is 30, and then plus a is Java, and d is already 30, right? So this would be like that. And then b plus a plus c plus d, right? This one, b plus a plus c plus d, we would get something like b plus a is, b is already 10, right? A is Java, and c plus d, what is c plus d? 20 and 30, right? 20 30. That is how this works. Again, if you follow the associativity rules, you will be able to get the answer correctly, right? Right. So that is about the string concatenation. I took a little bit time there because it was a little tricky concept to understand. Now we have increment and decrement, right? We have something known as increment operator. Basically, we have an operator like plus plus and minus minus, right? In Java we have this, and these operators, depending on the scenario, they are also known as pre-increment, post increment, pre-decrement, and post decrement. That depends on whether you use the plus plus before the variable or after the variable. Here again you are using before the variable and after the variable, right? But in essence they both do the same thing. The thing they generally just do is like if it is x plus plus, if it is a post increment or a pre increment, it's just adding one, to the remaining answer that you already have. In the same way, if it is x minus minus, it's just again adding, removing one from whatever the number that you have, right? So quickly let's go through this particular thing here, right? If I have x equal to 4, in the same way, if I do x, so if I do plus plus x, since we are having a plus plus before x, it is a pre increment, this particular thing. If it is a pre increment, what you generally do is you update the x first. You update the x. What is x now? X is now 5, right? And then you assign it to y. That is what happens. You update the x and then assign it to y. So the answer that you generally get here would be 5 and then 5 is what you will get here, right? In this particular, so this is one example, right? The other example here is, let's see, right? If you have x plus plus, something like x plus plus, what you generally do is you have to update after the semicolon, right? So x, whatever it is right now, will be assigned to y. So y is now 4, right? Y is in a box, 4 is in a box, and then that name is known as y, right? And then x will be incremented, right? So after the semicolon, x is definitely 5, right? But y is 4, Why is 4? And the reason is very simple, because it's a post increment. That's it, right? It will increment after the semicolon, right? In the same way, here you, since it is a pre decrement, x will decrement first, right? So x will be something like 4, right? The output would be, the answer of y would be 4. Oh, sorry. So this is 4 already, right? So if it is 4, then x would be 3, and then answer of y would also be 3. Here, in the same way, since it is a post decrement, x will decrement later. This is pre-decrement. This is post-decrement, right? X will decrement later. So after the semicolon, X will decrement. So before that, X will assign to Y, right? Y will have the value of whatever is X is storing now. So Y will be 4 before the decrement. So you can very blindly write 4 here. But since after the semicolon, X has already changed the value, you still have 3 here, right? So that is the very simple thing. Now there are some very tricky questions regarding increment, post increment, pre increment, right? So this is illegal in Java. You will get a compilation error here. This is wrong. You basically should not do this, right? This is not good, right? This looks nice, right? This particular problem actually looks nice, but what is happening is plus plus x is giving you 5, right? If you do plus plus x, you will get 5, and then again you will do plus plus on 5. This is the same situation as this, right? So this particular thing is also not correct, right? So this is also not correct. This you should not do something like this, and this is also not correct. You will get a error during runtime. This is a runtime error, right? This is a problem, right? So this particular here you are doing an x plus plus. This is legal, but since this is a final integer, right? If it is a final integer, that means you cannot change the x value. So this you will get a compilation error saying you cannot do this to a final integer, right? So you will get a compilation error. In the same way, here you have double d equal to 10.5 and d plus plus. This is the perfectly valid one, right? This is a perfectly valid one, and the answer you will get is 11.5. The answer is 11.5. So the out of these four, out of these particular things, all four, this is the only correct one. All of them are wrong, right? You cannot apply plus plus or minus minus on a literal like 4, and you cannot do something like this on the outside. It looks correct, but it is wrong. And you cannot, for a final value, if it is a final value, it is basically const, right? You cannot change a value that has been assigned to this, right? You cannot do x equal to x plus 1 or whatever, you cannot, right? So you will get a compilation error. Okay, that's all about this particular tricky questions regarding. And let's now move on to relational operators, right? In relational operators, we have this particular operators: less than or equal to, greater than or equal to, right? Let's quickly go through 10 less than 20. What is 10 less than 20? It should give you something like true, right? This is true. 200, is it less than 20? 100? No, you will get false. A less than z, you will get true, because essentially A and Z are characters, and internally in Java they are just 97, and this would be somewhere around 97 plus 26, whatever the value is, right? So 97 is definitely less than this value, so that is the reason you'll get true here. So this particular thing, 10 is not greater than 10.0. So Java will convert this particular element, element to an integer, and it will do the conversion, and internally it will get you a false. Right? And you have true less than false. This basically is a compilation error, because you cannot compare, cannot use relational operators, like relational operators in the sense, ops on Boolean data type, right? These operators, I'm talking about these particular operators, these ones. You cannot do that. You cannot say true is less than false or false is less than true. That is not logical, so that is not allowed. In the same way, you have Java less than C++. You cannot compare strings like this. Cannot compare strings like this, right? You have to go through, iterate through each and every one of them and then compare, right? So that we will look into later, but that's how Java is defined, right? So you cannot compare strings like this. Cool. So this also is going to give you like a compilation error, right? So that is one more problem. And this particular thing is interesting. Here what is happening is that again here operator precedence kicks in. The precedence is basically 10 less than 20 will happen first and then less than 30 will happen later, right? So 10 less than 20 will give you true, and now true less than 30, right? This does not make sense. This thing does not make sense, right? This thing does not make sense. Okay, so this is wrong. So this particular thing will error out during runtime. You will get a runtime error. Okay, this is a problem, right? Okay, so something like this won't work. Okay, now okay, yeah, so let's move on to equality operators. We generally just have two operators that are equality operators, just equal to and not equal to, right? Let's quickly go through what are the answers for this. 10 equal to 20, very obviously it is false. 10 is not equal to 20, and then 10 equal to 10, it is true, because 10 and 20 are equal. True equal to true, we can do this, right? We can definitely do this, right? But you cannot compare true and false in terms of less than, equal to, less than, greater than. All of those kind of things is not possible, right? This is perfectly valid. Okay, and true is not equal to false. Yes, this is also true, since they are not equal, right? And the answer for this would be 10 less than 20, right? Here we have 10 less than 20. The answer for this would be true. In the same way, for this would be, it would be false. Okay, cool. You understand? It's that simple, right? And now we have bitwise operators, right? In bitwise operators, you generally have three particular ones. One is and, so you have these three, right? These three you have. And is, sorry, one second, right? And is bitwise, bitwise and then you have or, which is bitwise or, right? And then you have XOR, right? This is bitwise XOR. So very simply, these are just bitwise operators, right? So if I do 10 and 20, what is actually happening is, or maybe let's just say 10 and 8, right? What is actually happening is, in the binary representation of 10, 10 is represented as this number 0 0 0 1 0 1 0. 8 is represented as 0 0 0 0 1 0 0, right? If I do an AND between them, bitwise they will be ANDed. This bit and this bit will AND, this bit and this bit. So every position bit will AND, and then you will get an answer, right? And here comes some little bit about the truth table, right? If I have A, B, if I want to find AND, if I want to find OR, if I want to find XOR, right? The truth table is very simple. Again, these are already, most of you might have already known this, but let's just reiterate. If I have like 0 0 0 1 1 0 1 1, right? For 0 0 you would get 0, 0 1 you'll get 0, 1 0 you'll get 0, and 1 1 you'll get 1. So this is about your AND, but basically AND, right? In the same way, for 0 0 you'll get 0, for 0 1 you'll get 1, 1 0 you'll get 1, for 1 1 you'll get 1, right? This is your you'll get your OR, right? XOR I'll explain. For now you understand that this is how and OR works, right? So from this table, what you can generally do is 0 and 0 will be 0, 1 and 0 would be 0, 0 and 0 would be 1, and only 1 and 1, only 1 and 1 would give you a 1 at the end, and then all of them are zeros because they are all 0 and zeros. This actually is 8, right? This actually is 8. So you will do bitwise ANDing, right? There is also one more operator, which is complement, right? Right. So complement is a unary operator, which is bitwise complement. You generally use this on one operand, used only on one operand, one only on one operand, right? Cool. So that is basically your bitwise. Right, okay, so let's continue. So this is AND, right? OR is again very simple. What you generally do is, if I have 10 and let's say 16, not 10 and 16, let's just say 10 or 15, right? Something like this. If 10 in binary is 0 0 0 1 0 1 0, and 15 in binary is 0 0 0 0 1 1 1 1, right? If I apply a OR on this, what happens is 0 or 1 with respect to our OR table, right? 0 and 1 is 1, 0 or 1, 1 or 0 is 1, 1 or 1 is 1. Why? Because if you have even a single truth value, answer would be true always, right? In AND, if we even have a single false value, answer would be, the complete answer would be false. So that is a very major difference between OR and AND, right? So 0 or 1 would be 0, 1 or 1 would be, sorry, 0 or 1 would not be 0 here. Since it is an OR, 0 or 1, 1 is true, so you will have 1, 1 or 1 is 1, 0 or 1 is 1, 1 or 1 is 1, right? Rest all are zeros. So your answer here is again 15, right? All the values are true, so you will get 15. If you want, you can do for another values as well. In the same way, we have something known as the XOR, right? XOR data type. So XOR, what we do is, what we generally do is, if I do 10 XOR 20, right? If I do 10 XOR 20, what we generally do is, we have 10 XOR 20, right? So 10 is 0 0 0 0 1 0 1 0, right? 20 is 16 plus 4, right? 0 0 0 1 0, and then 4 is here, and then this, right? So this is 20, right? If I do XOR on this, right? XOR, it's another name for XOR. Basically means modulo 2 sum, right? The best way to remember XOR is modulo 2 sum, right? And what do I mean by modulo 2 sum, right? If you have 0 and 0, right? If you have a equal to 0 and b equal to 0, right? What you generally do, you will first take a plus b and apply modulo 2 on that. That is your XOR. That's it, right? For any particular two values, if you have a and b, right, and if you sum them and apply modulo 2, that is your XOR, right? So for example, for 0 0 0 1 1 0 and 1 1, right? 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, this is 2. If you now apply modulo 2 on all of this, right, what will you get? Here modulo 2 would be 0, here modulo 2 would be 1, modulo 2 would be 1, and then modulo 2 would be 0. So you never remember that if they are same, it would be 0. If they are not same, it would be 1, something like that. If you remember this particular thing, right, if you remember that this is modulo 2 sum, that's it. That is the logic you need to remember, that you first take the sum of the values, and then you apply modulo 2 on top of that. That's it. You'll get the answer. So we can fill up the truth table with just this information, that is, it is 0 1 1 0, right? 0 1 1 0. You never need to remember how you can get this. You just need to remember that you are supposed to use modulo 2 sum, right? Modulo 2 the sum, modulo 2, apply modulo 2 on the sum. What is the sum? A plus b, and then apply modulo 2 to that, and you'll get the correct answer, right? So in the bitwise world, 0 and 0, right? According to our truth table, 0 and 0 is 0 and 0 is, what is 0 and 0? 0, right? 1 and 0 is 1. So 1 XOR 1, 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 0 is 1, 0 XOR 1 is 1, right? And then all zeros, right? What is this number? This number is 30, right? It should be 30, right? Because all of these numbers, if they are all ones, they will form 31, right? Minus this one, right? So this will be 30, right? This number is 30 in terms of normal English, right? Okay, so we are now going to look into, yeah, so we are now going to look into logical operators, right? One second. Yeah, logical operators, right? So before even moving to logical operators, we will go and look into our tilde, right? Tilde is a bitwise, so it is a bitwise, so it was bitwise, what do we say, complement. So basically what do I mean is bitwise complement is one's complement, is what I mean, simply speaking, right? So if I have number like if I have number like 10, and if I apply bitwise complement to this, so you cannot directly apply to a number, so this is wrong. You can actually apply to a number. So if I have int x equal to 10, right, and if I do s out, right, something like this, what will generally happen is that we will have 0 0 0 0 1 0 1 0, right? On this, if we apply a complement, you should get all zeros will become 1 and all ones will become 0. 1 1 1 1 0 1 0 1, right? The very easy way to do this is that for a positive number, you increment it by 1 and change the sign, right? So basically 10 plus 1 and then change the sign, you'll get minus 11, and that is what this number represents, right? This particular binary number. For if you're doing for a negative number, right? For example, int right, if for example if you are doing int y equal to uh, 8, right? If you're doing this, then if I do s out tilde y, then what you generally would get is something like, so this is, sorry, this is 8, right? You should just use minus 8 here, right? Okay, if you do something like this, then the answer that you should get here would be 7. That's what the answer is. Okay, you just increment by 1, right? Your answer. Okay, and all of those kind of things, right? The bitwise is pretty simple to understand, but there is more complication to it. So I'm going to minimize this particular thing and keep it here, right? So yeah, okay, yeah. So let's come to all logical operators. The operators we generally have in logical grounds is and, or, and I think these are the two operators that we have, and we also have logical not, right? So what we generally have is these are this is known as so these are actually also known as short circuit operators. Short circuit operators. Okay, before even moving forward, guys, I will extend the class by 10 minutes, right? So I will extend the class by 10 minutes, right? So before even moving forward, there I'll share a link with you, which is an attendance link, right? I'll share a link with you guys. One second. I'll share a link with you guys. Right. So this particular thing, I'll share it with you guys here. So you can, this is the form to fill up your attendance. Cool. And you can go ahead and fill up your attendance. Yeah, Hrutik, Gaud, I'll take a doubt session after 10 minutes, right? For now, let us complete operators, and then I'll take a doubt session, right? If you guys have any more doubts, I'll take a doubt session there. For now, let's concentrate on what I'm trying to tell you, right? So we generally have logical and then logical or, and then logical not, right? So these are also known as short circuit operators, and they are known as short circuit operators because we have a very good reasoning for them, right? And the reason is very simple, right? And just says, so something like, if I have a and b, right? I don't care about what their values are. Let's assume they are just true, they'll give some true or false values, right? If I have a and b, then what Java says is b will only execute if a is true, right? In the same way, if I have a or b, right, this again, here b will not execute, okay, if a is true. Or you can also think of this in another way, where b will only execute if a is untrue or a is false. In the same way, the above one, you can think of it as b will not execute if a is already false. Okay, so you are basically short circuiting the entire thing. So let's say you have a set of you know conditions that you need to check. For example, if the first condition, let's say if I have first condition, and if I have some second condition, something like that, right? And then if I have third condition, right? Whatever conditions I have, if my first condition itself is failing, right? I don't care about this. I am going to fail the entire expression, is what I'm trying to say. You are using this operator is used for that particular purpose, right? To have conditions that are chained, and you are supposed to you are supposed to short circuit the chaining, is what you are using. You basically chain the conditions such that your first condition takes the highest priority. If this is true, only then go and check what will happen of this condition. If this is true, go and check what will happen of this condition, and so on so forth, right? Once all of them are true, only then you will enter whatever body you want to enter, right? That is the whole scenario here, right? So this is all about logical operators. In the same way, for or as well, right? For or as well, you have like a condition x is there, right? Some condition y is there, or some condition z is there, right? What you can specifically understand from this is that if x is true, right, the rest all things ignored, basically. I don't really care about whatever is there after this particular or. Since I already have a truth value, I don't care, right? This is very useful when you want to do you want some of them to be true, right? If any of one of them is true, the entire expression is true. If any one of them is true, the entire expression is true. In this case, only all of them have to be true. This is something like a mathematical for all. This is something like a like for each, right? Something like that. Okay, if anyone knows these symbols, that's fine. If they don't, that's also fine, right? So this is like that. Okay, cool. So that is about your logical operators, right? So that is all about logical operators. And one more caveat is that bitwise operators and logical operators are not supposed to be confused. Bitwise operators, no matter what, they don't short circuit. Something like here, the the Java compiler will not even the Java runtime JVM, if this condition is false, it not even go to the second condition, right? That will not happen with like bitwise operators. For 10 or 5, both 10 and 5 will be converted to their bitwise levels, and then OR operator will be applied bitwise. So this will definitely happen, right? 10 is true, or so this is actually not OR. Here it is just OR, like this, right? Yeah, simple. Okay, so something like that. Okay, cool. You guys got an understanding of what this particular thing is. Let's very quickly move on to some more stuff. We will move on to um, so we will move on to ternary operators now. So we have something known as the ternary operators, right? Ternary operators, right? We have something known as the ternary operators, right? So in ternary operators, what you generally have is that you have a statement like, let's say, int x equal to, you have a expression here, and then this question mark, and if this expression is true, then true whatever is there here will execute. If this expression is false, whatever is there here will get assigned. Basically, whatever is there here will get assigned to x. Whatever is there here, if this is false, will assign to x. This particular thing, it's like writing this, right? If someone knows flow control, right, it's like writing int x, and then if expression, right, then x equal to some true, right, otherwise else x equal to false, is what this is basically. Instead of writing like a full if else condition, what you generally do is you just write a normal, just a single line, and that will suffice. So for example, so something like int x, if it is equal to 10, right, int y is equal to 20, right, then you can assign max. Max is if x is greater than y, right, you can assign x. You're saying if x is greater than y, right? You're saying if x is greater than y, my maximum should be x, otherwise it should be y, right? Your answer here would be, max would be something like, max would be what will be your max? Max will be 20, because y is actually greater than 20. So this will be false. This would be false. If this is false, your answer will come from the right side of the colon. Right? This is what ternary operator is. It's very simple. Right? When it comes to now, so there are two more topics remaining. Hold on, guys. Very simple, right? We have assignment operators as well. Assignment operators. In general, we have very simple kind of assignments, right? We have something like one simple assignment, right? Simple assignment. In simple assignment, what generally happens is, if you just do int x equal to 10, this is a simple assignment. And then you have second compound assignment. So in Java, this is also valid. Something like int x, y, z is there, right? If you want to assign all of them a value, x equal to, y equal to, z equal to -6, right? You can do this. This is valid in Java, right? And you have something like right, and you have something like compound assignment. So this is actually not a compound assignment, this is a chained assignment. Sorry, this is a chained assignment. Then you have a compound assignment. The compound assignment is basically when you can use an operator with the assignment value. Like for example, if I have something, so basically the operators that you generally have are plus equal to, minus equal to, division equal to, modulo equal to, multiplication equal to. So these are the ones that are compound assignment statements, right? And so the way you generally do it is you use int, let's say x equal to 10, right? If you just do x plus equal to 900, right? This basically is the same as x equal to x plus 900, right? And if you do something like x minus equal to 50, right? This is same as x equal to x minus 50, right? So that's about compound assignment. And then one more thing is we will look into what typecasting is, right? Typecasting, right? After this I'll take a doubt session so that you guys can clarify all your doubts right now. Okay. So basically what we generally do is in your normal typecasting, right? It's basically the process. It's simply convert one type to another type is what this is. To another type. This is the process of converting between types, right? Uh, basically there are two types, two ways of typecasting. I am not going to use types. Two ways of typecasting. One is one is known as implicit typecasting, and the another is known as explicit typecasting. Right? In the implicit form, basically the compile. So in the implicit form, what I can say is, right, if you have double d equal to 10, right, by default the compiler knows that 10 is supposed to be a integer, right? 10 is supposed to be a int value, but since it saw that there is a double here, right, there is a double here, right, what it will do is it will convert it internally, right, this particular number internally converted to 10.0, right? So that is the reason implicit type conversion is always handled by the compiler. And also this is sometimes also known as upcasting or widening. Also we have more examples like this, right? Again, you can obviously take one more example where one integer, or maybe not integer, long y equal to 500, right? Here also 500 is supposed to be an integer. By default it is an integer, but internally compiler, your javac, right, your compiler, your javac takes care of doing the typecasting, right? That is the major advantage of this particular thing, right? And the way it is doing is it internally has a small way of understanding what types can go into what types. And the way it generally upcasts or widens is, first is byte, then there is short, then there is int, then there is long, and then you have double, sorry, not double, right? So till long it will upcast, right? So from int you can also, it will upcast to float, and from float it will upcast to double, right? So that is how this particular table is. And char some comes somewhere between here, right? So if you assign a character to an integer, it's fine. But if you assign a integer to a character, right, then that is a problem, right? If I try to do something like char ch equal to 600, right, this might not throw an error, but this is a problem because this here is considered as an integer, right? It is always better to, if it is considered an integer, it will take 4 bytes, right? This will only be able to hold 6 bytes. Sorry, not 6 bytes, sorry, 2 bytes, right? So what it will do is it will cut the entire thing into half, and then take the remaining, like whatever is there in your 32 bytes, it will take only this particular portion and assign it to ch, right? That is what will happen, right? And so that is loss of information, right? So this particular thing generally is not possible in your Java. So what you generally do to circumvent this particular thing is that you just do char ch equal to a, not int. You just do char of int. Sorry, not char of int. So you'll write character, saying I need a character for 600, right? If you do this, you are doing a typecasting, right? You're doing an explicitly typecast, right? Because this is very normal, this is very natural. So something like int z equal to some character a is fine, but something like char ch equal to 600 is not fine, because that is a downcasting, right? So this is also known as downcasting or narrowing, right? So this is all about this particular narrowing and all, right? So downcasting or narrowing. So you have to explicitly say that this is fine, whatever I'm doing is correct, it's not going to hurt the thing, like, right? So here there is a loss of data, very simply speaking. Here loss of data, there is a loss of data, right? uh, yeah, so information is always lost. So something like double d equal to 0.57, right? If I do double d equal to 0.57, and if I store it as an int x equal to d, right? If I do d, what will happen is, first of all, this is generally not possible, right? So what you generally do is you will just say I'm going to typecast it as int and I'm going to do restore it as d, right? But when you do that, what happens? Your information is lost and you'll store 0, right? But you actually wanted to store 0.57, right? But yeah, so sometimes the information is lost and so you have to deal with it, right? So that is how typecasting works. So this is all about this particular lecture. There is a lot of things that have been covered in this lecture, and yeah, I'll be open to doubts right now, and yeah, maybe you guys can uh, uh, see you guys can ask me doubts that you can, right? Yeah, go ahead. Hello. We will cover methods and other parts, flow control methods, and call by value, remaining topics in the next lecture. Yeah. Guys, you can if any of you are there here, you can go ahead and ask doubts. Whatever are the doubts, you can go ahead and ask. So from the starting to ending, whatever doubts you have, I'll try to clear them right now and maybe explain new stuff, right? Yeah, I think I'll let my team know. My right, CodeSprint team will share the notes. Yeah. So yeah, Yes, the notes will be shared. If you guys have any doubts, just ask me. I see that there is one doubt. I can see that there is one doubt. And obviously, guys, don't forget to like, share, and subscribe. Right? You guys can like and share because this content takes little time to write and arrange, and you guys can see, right? Yeah. So if you guys have any doubts, just explain. So Hrithik Gaud actually asked me, can you give another example for bitwise operators? What do you mean by another example of bitwise operators? Which particular bitwise operator do you need an example of? All bitwise operators or just some of them? Hello, Hrithik, if you are there. Hello. Hey, Hrithik, are you there? Right, I'm going to wait for some more time for like 2 more minutes. And if you guys have any doubts, just ask me. I'll try to clarify them. Definitely, these notes will be shared across your WhatsApp group or like some Google Drive or somewhere. I'll definitely share the notes. Yeah. Hello. And let me know if you guys have any doubts, right? If you guys have any doubts, you can obviously ask me in the WhatsApp group as well, or yeah, or you can ask me tomorrow in the beginning of the class, or like maybe tomorrow you can ask me in the end. You still have a way to ask doubts. If it is possible, please go ahead and ask me doubts. I'm gonna wait till 8 2 more minutes, and then I'm gonna end the stream. So guys, if before that, if you have any doubts, please go ahead and ask me. There are many topics that I covered, and you might need to revise the entire topics again. You might need to see the entire video, and maybe you will have to understand it again. But please go ahead and ask me doubts if you guys have any. Yeah, it seems there is no one who is asking any doubts right now. uh, I think everybody understood the entire things, all the things. I guess everyone understood everything here. Everyone is a genius, I guess, right? I think these are all basic topics, so yeah. Cool. So you guys can see the form that I have mentioned above. So for you to get your particular, uh, what do we say, the certificate, you just definitely have to fill up the form. Um, right? And yeah, if you guys have any doubts, right, ask over tomorrow, right? If you like go through the content, I'll share the notes as soon as possible, and then go through the content, and you guys can ask me doubts. Cool. If that is cool, I'll take my leave. Thank you, and good night. Bye, guys.